Okay, I think I'm live now. Can someone confirm in the chat? Okay, लॉजिक सी कोई बोल रहा था Okay, so am I live? Can someone confirm in the chat? He seems to be. It is just an integer partition. The numbers available. Okay, perfect. Okay, cool. I can see I'm live. Alright, so we'll be solving Codeforces round 785 Div-2 today. And I'll be doing problem A, B, C, and D of this contest. But first, I would actually like to know like how many problems you all were able to solve. Maybe A, B, C, what all. So let's see. B का logic and even. I'll tell the logic of B as well. Two when I says two, A only. From bullet says. That says okay. Anyone who was able to do A, B, C, and D maybe, or A, B, C. How many were able to do C? So that says A, B. Okay, I see. Yeah, okay. C actually has very less submission. Okay. Friday but not pass. Okay. Atharva says two. Cool. Okay, I see many people want to know the solutions of C and D today then. Okay, cool. Let's start with problem A then. I think we should start now. We have 30 viewers at the moment. That's cool. Do like the stream, guys. I only have 16 likes. Make sure to like the stream. Okay, cool. Let's start with problem A. Problem A says that Alice and Bob are playing a game with strings. There will be T rounds in the game. In each round, there will be a string S consisting of lowercase English letters. Okay, so there are T rounds. Okay, and in every round, we have a string S. Okay, now adding Alice moves first and both the players take alternate turns. Alice is allowing to remove any substring of even length and Bob is allowed to remove any substring of odd length. Okay, so if this is the complete string, Alice can actually remove any substring which is of even length. Okay, and odd can be removed by Bob and Alice moves first. Okay, more formally, if there was a string S, the player can choose a substring this with length of corresponding parity and remove it. After that, the string will become okay. So you just remove the substring from the between. After the string becomes empty, the round ends and each player calculates his or her score for this round. The score of a player is the sum of values of all characters removed by him, her. Okay, score value of A is 1, B is 2, C is 3, and Z is 26. The player with higher score wins the round. For each round, determine the winner and the difference between winner and losers. Course, okay. So Alice moves first. Next is Bob. Okay, and Alice moves when it is an even substring, and Bob moves when it's an odd substring. So let's say you had a complete string. Okay, this was the complete string. Okay, and in this string, let's say this is even for now, and Alice has to move first. So what Alice will do is he will actually take the complete array, because a complete array is also a substring of itself. Okay, and taking the complete array means Bob will get 0, and we can actually count the value of Alice by counting all the value of significant indexes and then add them up, and that is the score of Alice. But if it's an odd value, if it's an odd string, what you can do is you can either take the first n-1 characters or the last n-1 characters or the last n-1 characters, whichever has the maximum value. Okay, that will be taken by Alice because the complete string is odd. So you take one less than the complete string. So that will be even. So this part will be even. Okay, Alice takes whichever is the greatest and then leaves one single character for Bob. Okay, and that's it. In the end, you just have to print the difference of Alice score and Bob's score. So I'll quickly show my code. Okay. Okay, so this is the code. What I'm actually doing is first I'm iterating the complete array and assuming that Alice takes everything. Okay. Now If the string is odd, what you need to do is you need to take one character and give that to Bob. But Alice will keep that part which has the maximum value. So essentially, Bob will either get the first character or the last character, whichever has the least value, that will be given to Bob, because the bigger one will be taken by Alice already. So what you need to do is you need to find if the first character has the bigger value or the last character has a bigger value. Okay, whichever has the smaller value, you give that to Bob. Subtract that value from Alice because we gave Alice everything. So we need to remove that value from Alice. And now you see if the score of Alice is greater than Bob, then print Alice and then the difference of both the scores. Otherwise, print Bob and the difference of both the scores. Okay, cool. So that's problem A. I'm pretty sure now everyone knows how to solve problem A. Sandesh says 3. Hi, hello, how are you doing? Poor me, always coming last. Hi, how many questions did you solve? Okay, cool. Okay, I think problem A is clear to everyone and we can move to problem B now. All right, so let me open problem B. Okay, let's come to problem B now. Or let me just put the submission link, okay, in the chat. All right, cool. Okay, let's move to problem B now. Now, let's call a string S perfectly balanced if for all possible triplets T, U, and V such that T is a non-empty substring of S and U and V are characters of present in S. Okay, so we have the string T is nothing but a substring. U and V are characters in the string. Now notice these two are characters in the string, not the substring. And you have a triplet of T, U, and V. For example, the string ABA, ABC are perfectly balanced, but ABB is not because the triplet, the condition is not satisfied. So basically, what they're saying is that in ABB, if you take this substring, okay, so T becomes PB. Let's say U is B and V is A. Now count of B is 2 in this substring, count of A in this substring is 0. Okay, since the difference is greater than 1, okay, therefore we can say that this is not a balanced substring. But if you took, instead of this, if you took what? ABA, and let's say T was the complete string only ABA. Now U is B and V is A, considering there are only two characters. Okay, now count of B is 1, count of A is 2. The difference of these is 1, which is not greater than 1. Therefore, we can say this is a balanced one. Okay, let's take another substring. Let's say we take AB or BA, because these two are the only substrings left. Now, U is B, V is A. Count of B is 1, A is 1. Difference is 0, which is not greater than 1. Therefore, we can say this string is a balanced string. Now, how the answer of AAA is yes. The answer of AAA is yes because let's say T is the complete string only. Now, U is A, and if you see, U and V should be characters in the string. T has only A as its character, therefore V will also be A. Now, count of U is 5 and count of V is also 5 and difference is 0. Okay, that's why the answer for this one is yes. Now, how to solve this? Let's say we had a string A, B, C, or say let's say A, B, C, A, and let's say this is T. Okay, if you see in this U is A and V is B, count of A is 2, B is 1. No problem. Okay, we will see that. Okay, what are all the pairs of U and V? Pairs of U and V are either you can take AB or you can take BC, or you can take CA. These are all the pairs of U and V possible. Let's say I wanted to insert another character after this. What is the only character present in this string which I can move here? Okay, let's say my complete string was A, B, C and A, and I want something else in the string as well. What is the other character that I can add here such that this string, complete string, is a balanced string? Let's try adding an A. If we add an A here, okay, if we add an A here, okay, you will see that if you take T as A, and if you take this pair, count of A becomes 2, count of B becomes 0, and hence this is not a balanced pair. Let's remove this and let's see if we can insert C here. If we inserted C here and if we took what? Okay, for C it is not going wrong. Okay, so we can insert C. That is possible. Okay, if you see for C, let's take this one also, CAC. Okay, count of C is 2, A is 1. Okay, so possible. But if you took this one, this pair, count of C is 2, but count of B is 0. Since count of B is 0, count of C is 2, difference becomes 2. Hence, this is not a balanced substring. Hence, this complete string is not balanced. So, we cannot take C also. Let's say we took some random string. Let's say we try to insert D here. If we try to insert D here, okay, and if we took this as a substring, A, B, C and A. Okay. And now if you try for this case only, okay, in A, you have a count of A is 2, count of B is 1. Sorry, count of B is 1, right, count of B is 1. Okay, so possible. But if you see, there is another pair of U and V possible now, A and D, because we have inserted a unique character. Count of A in this substring is 2, count of D is 0. Therefore, again, not possible. Therefore, this is not a balanced string. So you can not insert D also. Now, if you see, we saw that we could not insert A here. We could not insert C here. We could not insert anything new, which is D here. The only possible case left is B. Okay, the only possible case left is B. And if you see, if you inserted a B here, it is a balanced string. If you took any character, okay, if you took any substring, it is a balanced substring. Let's say if you took this one also, B, C, A, B. For this case, count of A is 1, count of B is 2, so possible. For this case, count of B is 2, count of C is 1, so possible. For this case, count of C is 1, count of A is 1, so possible. So if you say there is no substring which is not balanced, therefore this complete string is balanced. Now if you try for the next character, let's say you wanted to insert another character, you will see that C is the only possible character. Instead of C, if you try to insert any other character, it won't be possible. And now if you see, there is a pattern emerging. You had ABC first, then again you needed an ABC. After this, you'll need another ABC if you want to add any more characters. So essentially, what we have to do is, we first have to find a pair unique sequence, okay, which has all the unique characters. So let's say AB only. And then all the rest of the string should be a repetition of this AB only. So if you had AB here, the rest of the string should be AB, 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 and so on. If anywhere this pattern breaks, then the answer becomes no. Otherwise, the answer is yes. And that's it. So if you took, if you see all the examples also, you will see in the very first case, okay, you will see in the very first case, we had ABA. When we had ABA, AB was the sequence that you took, and then you just had to keep repeating it. So you just repeated half of this, and the answer of this becomes yes. In the next one, we had ABB. In this, the unique sequence that you had to take was AB. And if you see, if you try to repeat this, ABB would never be possible. Therefore, the answer of this is no. In the next case, we have ABC. ABC in itself is a unique string. Therefore, you don't need to add. But if you wanted to add, you had to add ABC and so on only. Okay, but since you had ABC only, the answer of this is yes. The next is A. And in this, if you see, A single A is the string that you had to take, and now since this is the pattern that you need to keep on repeating, you repeated it 5 times, and the answer of this is yes. And in the last case, we have A, B, C, B, A. If you see, ABC is the pattern that you have to take, and after that, it should be AB only instead of BA. Since it is BA, the answer of this is, and that's it. That is all you had to do. Okay, okay, let me even show you the code, and then I'll read the chart. Okay, so this is the code. Okay, and I'll even paste the link to this. Okay, cool. Okay, so let me just explain like what I'm actually doing here. Let's say we had the string ABC, ABC, AB. Indexes was 0, 1, 2, 3, 4, 5, 6, 7. Now, if you see what I'm actually doing here is I scanned the complete string, then I have the length of the string, then I have a map of character int. What I'm actually doing is in this for loop, I'm just iterating over the complete string. And whenever I find an index which is already present in my map, then I break out of this loop and mark my index as I. So basically, when I first received A, I say that my count of A is 1. I go into this else and I say that count of A is 1. When I receive B, I say count of B is 1. When I receive C, count of C is 1. But then when I come on to this A again, this is A actually, A and B. When I come on to this A again, I'll see that A is already present in the map. Since it is already present in the map, I will make my index equals to the index of this, which is 3, and then break out of this loop. After that, what I'm actually doing is I'm iterating my for loop again and then checking from this index. Okay, from this index, I just see that if my what s of I should not be equal to s of I percentage index. So basically, s of I is my current value. This should not be equal to s of what I percentage index. Index is 3. So when I'm at index 3, s of I is 3 only. So s of 3 should not be equal to s of p percentage 3, which is 0. Okay. So third index should be equal to 0th index. Third index should be equal to 0th index, which it is. When I becomes 4, it will be s of 4 not be equal to s of 4 percentage 3, which is 1. S of 1. Fourth index should be equal to 1. Okay, and so on. That is all you had to do. Okay, let me just read the chart now. We have a lot of chart. Okay. I sort the string. Okay, this is problem A. Okay, on the record, I did the same mistake. I was mentioned that if it was a substring, not a subsequence, I did ABC because there is only one unique character. Bhaiya, during the contest, my B got AC, but now it's showing wrong answer on test case 5. I had also experienced it in the previous contest. Bhaiya, can you tell me the reason for this? Basically, Karthik, what is happening is you actually were able to pass all the pre-tests, and then in the system testing, your submission failed on test case 5. So basically, what Codeforces does is Codeforces has way too many problems in the starting. Okay, it has like test cases. It has almost 100 test cases for every problem. What it does is it actually tests your code for some 5-6 test cases first, and then like if they are passed, then it shows pretest pass, and then in the end, like after the contest, it checks for all the other test cases as well. The reason for doing this is because it takes a lot of load time to like actually check for all the test cases, and we cannot do that in a live contest. So it just checks for some test cases in the starting. So basically, you failed on any one of the system on 5th system test, and therefore you are getting a wrong answer now. And when we sort the string character orders were changed. Okay, got it. I took 3 cases when all this same print yes, when first and last are same, and all the letters between them are unique. Then yes. When the string is like ABAB, then also yes. But it is yes. Now I think Ashish, you know like why it is why your code is giving a wrong answer. Same method by wrong answer test case 2. That shouldn't be the case. Connect with me. Okay, hey Tiwari, you uninstall. Okay, I got the solution but could not implement. Pranshu, B can be simply solved using checking all substrings of size, distinct character in the string. It's exactly that is what I've done. The same logic, but couldn't intend. Priyanshu did the same. Okay, same here as well. Okay, I never solved this problem. Videos lacking evidence so clean. What is your thought process? Okay, I think I explained my thought process. Like my thought process was this only, that if I have a balanced string, what is the next character that I need to keep the string as a balanced one? Okay, so that is exactly how I actually explained as well. Is C solved using recursion backtracking? I'll explain like how you need to do C. Then D. Okay, cool. I think problem B is also clear to everyone now. Okay, and we can move on to problem what? C now. Cool. Let's move on to problem C. Okay. All right. So we are on problem C now. Uh, all right. Cool. Now in problem C, we are given that you're given a positive integer n. Let's call some positive integer a without leading zeros palindromic if it remains the same after reversing the order of the digits. Find the number of distinct ways to express n as the sum of positive palindromic integers. Two ways are considered different if the frequency of at least one palindromic integer is different in them. For example, 5 equals to 4 plus. Okay, cool. So basically what you had to do was, okay, for problem, you are saying your code will fail for ABC, ACB. Yes, exactly, because it is A, B, C, A, C, B. Yes, exactly, because it is actually a wrong, like, it should be no only, because for this given string, CAC, count of C is 2, but count of B is 0. And hence, the difference is greater than 1, therefore no. Alright, cool. Coming on to this question. So, basically, for 5, we have what? How many? Okay, let's start with 1 only. Okay. For 1, there's only one case, write 1. For 2, we have two cases, 1 plus 1 or 2. For 3, we have what? 1 plus 1 plus 1. We have 1 plus 2 and 3. For 4, we have 1 plus 1 plus 1 plus 1. Or we could have 1 plus 1 plus 2. Or we could have 2 plus 2. Or we could have 3 plus 1 or 4. So 5 cases. And for 5, it is already given that we have 7 cases. Okay. So you need to find this for any given n. Okay. Now, if you see, n is actually what? 4 into 10 to the power 4, but you have 10 to the power 4 test cases. Okay. So you need something like if you even do, okay, so your test cases are 10 to the power 4. Your n is also 10 to the power 4. So even if you write a code which is n time, like O of n for every test case, n times t will be 10 to the power 8, which will actually fail 4 times 10 to the power 8 because n is 4 into 10 to the power 4. Okay. This will actually give you a TLE. Therefore, what you need to do is you need to pre-compute for all n's first. Okay, and then for every test case, so basically pre-computation should take O of n only or O of n log n, and then for every test case you should return the answer in O of 1. How do you, like, I myself was actually a little confused, like maybe this might fit into the constraints. So what I did was I just wrote an n square brute force and tried to submit it and got a TLE on first case only. Okay, so I just wrote a very simple brute force and saw that if it works, it gave me a TLA. That actually meant that I need to pre-compute for every test case and then do it. Okay, so how to do this now? Okay, now if you see, let's forget about palindromes. Okay, let's forget that we need palindromic numbers in order to make the sum. Let's say that we can take any kind of numbers, and let's say we had what? Okay, let me just remove my screen. Okay, let's say I had one, I had 1, 2, 3, and let's say I only had one. If I only had one, the number of ways to make one would be one only. The number of ways to make one would be one only because we can make 1 plus 1 only. The number of ways to make 3 would be 1. Okay, and for 3 will be 1 because we can make 1 plus 1 plus 1 only. And for 4 also 1 again. And for 5 also 1 because we can make 1 plus 1 plus 1 plus 1 plus 1 only. Okay, so this is done. Now, what are the total number of ways we can make 1 if we had a 2 as well? This will be the number of ways we were able to make 1 using only 1 plus making 2. Now, since 2 is greater than 1, therefore it will be 1 only because the previous will be the answer only. But for this one now, okay, when you get a 2 and you also have a 2 in place, what you can do is you can actually add this 2 as well. So if this is n, let's say, and if you're taking 2, so you need to see the number of ways of making n minus 2 now. For 0, we have what? 0, 0 only. Okay. So if you see for 2 now, this becomes 2. The reason for this is because there is one way using 2 and one way was already present. Now, if we come on to 3, okay, if we come on to 3, you will see that we can either have what? We can either have the previous case only, so 1 plus, okay, when we didn't have 2. But now since we have a 2, okay, since we have a 2, what we can do is we can actually use this 2 for this one, and so we use 2, and now whatever is the left of it, 3 minus 1, which is how many ways do we have of making 1 when we have 1 and 2 both? That is this one. Okay, so another way, because we first used 2 and then rest of the part was made when we had 1 and 2 both, and whatever was the difference left, which was this one. So again 1 plus 1. Now coming on to this 4. Okay, how do we make this 4? One way would be we can either leave this 2 and make it from the above cases only, so we have 1 here from the previous case. Okay, other way would be we can actually use this 2. So we make 2 plus, now whatever is the left of the sum, which is 2 only, the number of ways of making 2 when we have 1 and 2 both, which is 2. So I actually write it here 2. The 2 ways are actually 2 plus 1 plus 1 and 2 plus 2. Okay, now coming on to 5. For 5, you will see that either you can keep this 2 removed and you had one case from the previous one, or what you can do is 2 plus, you can use 1, 2 and see the difference, which is 5 minus 2, which is actually 3. The number of ways of making 3 when you had 1 and 2 both, which was 1 plus 1, which is 2. So 1 plus 2. So this is 2, this is 3, and this is also 3. Okay. Now if you come to, let's say you had a 3 as well. If you had a 3, you will say that since this 3 is greater than 1, the answer will remain same, because you cannot use this 3 for this one. Similarly for 2 also, it will remain 2. But when you come on to 3, you will say that either I can keep this 3 removed, so answer will be 2 plus, or I can actually use this 3. So this is 3 plus 3 minus 3. This is 0. So the number of ways of making 0 when you have 1, 2 and 3, which is 0. So 2 plus 0. Sorry, this is 1 actually. Sorry. Okay. So this actually gives you one case. So you write 1 here. Okay. This is 1 because the number of ways of making 0 when you have a 1. That is one way that you don't take anything. Similarly, the number of ways of making 0 when you have 1 and 2 both is 1 also. Again, you don't take anything. That is one way. So then coming on to 4, you will see that you can either keep this 3 removed and your cases will be 3 only, or you can actually make use of this 3. So this becomes 3 plus the number of ways of making 4 minus 3, which is 1. The number of ways of making 1 when you have 1, 2 and 3, which is this one, plus 1. For 5, similarly, you can either keep this 3 removed, so it will be 3 plus, or you can use this 3, so this becomes 3 plus the number of ways of making 5 minus 3, which is 2. So the number of ways of making 2 when you have 1, 2 and 3, which is 2. So 3 plus 2. So this is 3, this is 4 now, and this is 5. And so on, you can keep on going till n. Okay. And till n, for every case, you'll actually get the answer. Okay. This is known as coin change problem. This is a very famous problem, and this is actually coin change. So you can just Google this up and like read it. Okay. Now, the thing is that you can not actually run this n into n loop. Okay. But if you see in the problem, it is mentioned that we can only use palindromic numbers. Okay. So let's see how many palindromic numbers do we have from 1 till 4 into 10 to the power 4, because that is the constraint for n. So basically n. Let's see. So we have numbers from 1, 2, 3 till 9. These are all palindromic numbers. Then we have what? 11, 22, so on till 99. Then we have 101, 111, 121 till 191. Then we have what? Then we have 202. Then you have 212. Then you have 222. So on till 292. So on till 909, 919. So on till 999. Then after this, you have 1001. You have 1111. You have 12221, and so on till 1991. And same thing continues till 9009, 9119, so on till 999. So if you see, these are what? 10 cases times 9. So these are 90 cases. Okay. Similarly, these are also 90 cases. I think I missed something. These are also 90 cases. Okay. These are 9 cases and these are 9 cases. Did I miss anything? I think I'm missing some cases. Anyways, whatever cases I'm missing, I'm pretty sure that sum of all these values will be very less. So what I can actually do is, first I can find all these values which are already a palindrome. Okay. 5-digit ones. Oh, yeah, sorry. It is 4 into 10 to the power 4. So you can actually have like 1, 0, 0, 0, 1. Then you can have 1, 1, 1, 1, 1, and so on. And then for like till 4994. So these will also be some cases. Okay. Anyways, I know that sum of all these values will be around 100. Okay. So what I can do is I can actually pre-populate a vector with all these numbers which are a palindrome. And then do this exact same thing for these numbers only. So in the left side, I'll have only these numbers. Okay. And that is how you have to do this complete problem. Okay. Let me just show you the code as well. It might be that some of you won't be able to understand like what I did here. What you need to do is you need to first understand what a coin change problem is. And then you'll be able to understand like what I'm actually doing here. Okay. I'll quickly show my code as well. Okay. So let me show my. Okay. Okay, cool. So what I'm actually doing is the very first thing that I'm doing is I'm just running a loop from 1 till 4 iterated into the power 4. The reason for this loop is because I need to find all the values which are a palindrome. To do that, what I'm actually doing is I'm taking this I into a string, then into ABC, and then reversing this complete string, then checking if this reverse is true, equal to the previous like unreversed one. If the both are same, then I just push these into a vector. This vector actually contains all the values which are a palindrome. Okay. Then this is the code for coin change. Okay. So what I do is for every value in this vector, I run the loop from that value till the greater values, because that value will be added only to those cases only, and then I increment those values. Okay, so this part is coin change. Maybe you can understand it from a better website or something, but the logic is this only what I explained. Okay, then in table I actually store the answer of every case and then just print the answer. That's it. One important thing to note here was that you actually had to take mod. Okay, so this is the reason like why I got 2 wrong. Okay, I actually first I missed this mod. Okay, and in the next case I actually missed a 0 here. So I got 2 wrong answers for no reason. Okay, anyways, is this clear to everyone now? Okay, maybe the code is not clear. You can actually just spend some time with the code and then try to understand like what I'm actually doing here in this part. But I hope the logic is clear to everyone. What is the time complexity of this? Time complexity of this code is this takes O of n, because it is just a loop of O of n. This takes size of v is actually 500 only. I know that. Okay, so 500 into n. So it is n into 500. Okay, and this is O of 1 only, like O of t. So the complete complexity becomes 500 into n. Can you explain again in short, please? Okay, cool. I'll explain again in short. Okay. So I hope this part is clear to everyone, that we can actually find the number of palindromes that we have. Okay, I hope this is clear to everyone. I'll again explain the other part, okay, which was coin change. Okay. Okay. Just rub everything and explain it again. Just the coin change part. Okay. We'll even write coin change. Okay, cool. So let's say 0, 1, 2. Okay. Let's say this is my sum, the sum that I want to make. Okay. And these are my values. Okay. Let's say in the starting I had a 1 only. Okay. If I only had a 1, what are the total number of ways of making a sum of 0? The total number of ways of making a sum of 0 is 1, because the way would be don't take anything and it becomes 0. So that is one way. Now, what are the total number of ways of making a sum of 1, 2, 3, 4, and what are the total number of ways of making a sum of 1? If you have 1 only, that will be 1 only, because you can only take one single one. Similarly, what are the total number of ways of making 2 when you only have 1 as a value? It is 1 plus 1. So that makes one case. Okay. Now, similarly, the number of ways of making 3 as a sum when you only have 1, so, which is 1 plus 1 plus 1 only, so one case. Similarly, for 4 also 1 and for 5 also 1. Now, what if we add another value of 2? Since this 2 is greater than 0, therefore no change here, no change here, because you cannot use this 2 coin for any of these coins. Let's say these are coins actually, and this is the total number of amount you want to make. But when you come on to this case, you will see that you could either keep this 2 aside and consider that you only had a 1. So that actually gave you one way. So 1 comes here. Or you could actually make use of this 2. So your sum is 2. You took 2 plus sum minus the value you are taking. So this is 0, which means the number of ways of making 0 when you have 1 and 2, which is this one. So you add 1 here. Similarly, when you come on to this 3, you will say that you can either keep this 2 aside and consider only 1 that had one way, or you could actually make use of this 2, which means add 2 plus what is the difference of 2, which is 3 minus 2, which is 1. So the number of ways of making 1 when you have 1 and 2, which is this one, you add 1 here. Then coming on to this 4, you will say that you could either keep this 2 aside, consider this 1 only, and you already know that you had one pair, you write 1 here, or you could actually make use of this 2, which means 2 plus 4 minus 2. This 4 minus 2 is 2. That means the number of ways of making 2 when you have 1 and 2 both, which is 1 plus 1, which is 2. So you write 2 here. Similarly, when you come on to the next case, which is this one, okay, you can either keep this 2 aside, consider 1 only, and you already had a 1 combination, or you could make use of this 2. So this becomes 2 plus 5 minus 2, which is 3. That means number of ways of making 3 when you have 1 and 2 both, which is 2. So 1 plus 2. Now I can just write this is 2, this is 2, this is 3, this is 3. This 3 signifies that what are the total number of ways of making 4 when I have a value of 1 and 2 only. Can we try to make this 3 cases? These 3 cases are 1 plus 1 plus 1, or 1 plus 1 plus 2, or 2 plus 2. These are the 3 cases. Okay. And similarly, you can keep on going for 3, 4 till n. But you already knew that the only values you can use in this particular problem is the values which are already a palindrome. So you could actually take all those palindromic numbers, find them, and you will see that the count of those numbers is 500 only. So in total, you will have 500 values here and n here. So this table will actually be of 500 into n only, and this will be the complexity as well. And that is how you have to solve this problem. Okay. I hope this problem is also clear to everyone now. Let me just read the chart. It's a great it is clear, great explanation, thank you. यार सी कितना सिंपल था. If you know coin change but contest में नहीं कर पाए, सोचने में सोच भी लेते तो implement नहीं कर पाते. You always write clean code. Thank you हितेश. मैं हमेशा सारे डीपी प्रॉब्लम्स तो मेमो से करने का ट्राई करता हूँ, सो इसमें भी नहीं कर पाता. Okay, cool. Anyways, I hope problem C is also clear to everyone. I'll again just take the link and paste it in the comments, chat, so that you can just see problem C. Okay, cool. Let's move on to problem D now. Okay, which is lost arithmetic progression. Okay. I hope problem A, B, C are clear to everyone now. Is there anyone who still doesn't understand any problems from A, B, C? Okay. Okay. Let's move on to problem D now. Okay. So in problem D, we are given that long ago you thought of two finite arithmetic progressions A and B. Okay, so we have two progressions A and B. Both of these are AP. Okay, arithmetic progression and finite. Okay, then you find out another sequence C containing all elements common to both A and B. So you have a C sequence which actually contains all the values which are common in A and B. So all the common values of A and B came into C. Okay, now it is not hard to see that C is also a finite arithmetic progression. Again, this will be an arithmetic progression only because you have common values of A and B. So this will be an AP only. Now, it's okay. After many years, you forgot that A was, but you forgot A, but was, but remember B and C. You are for some reason determined to find the lost arithmetic progression before you begin this eternal search. You want to know how many different finite arithmetic progressions exist, which can be your lost progression A. Okay, so let me just make the problem clear. What the problem is trying to say. Let's take a test case. Which one should I take? Let me take. Which test case should I take? Let's take this one. No, this is a rather large test. Which one should? Okay, I'll explain from this one only, from the second test case. So basically, what the problem? So we are actually given what? Okay, I'll write the test case. The test case is -9, 3, 11, and 0, 6. Okay. Now, Harshit says, can you please explain through recursion? I'm actually on the next question now. Maybe after this, I'll explain the recursion one if you want. Okay. Now, this is the input. What this input says is that this is, which one? This is, I think, B. Yeah. This is B. And this is C. I think you're not able to see this. Okay. Cool. Okay. Now, anyways, okay, this is 0, 6, and 3. This is 9 minus 3, -9, 3, and 11. This 9 is actually the starting of B. Okay, so this is actually A of B. Okay, let's call it AB only. That B is, okay, let's see. So our AP B is starting from -9. So we have -9. And if you see, we have -9 here. This is the BAP. What this means is that we start from -9. Our difference is 3. So after -9, you'll have -6, then you'll have -3, and so on. And in total, you have 11 elements. Okay, so these are the 11 elements that you have. And our C is 0, 6, 12. C is 0, 6, 3 actually, which means we start from 0, difference is 6, and in total we have 3 values. So we start from 0, the difference is 6, and in total we have 3 values. So 0, 6, 12. Okay, I hope this is clear. I hope the input is clear to everyone now. Now, these are the 10 possible arrangements of A possible. How? We'll see. If you see, in any of these A's, if you find out the common values between any A and B, let's say in this one, you will see that only 0, 6, and 12 are common between A and B. That means this is the C, this C is possible. Okay, and all the other values 2, 4, 8, 10, 14, 16 are not present in B as well. Okay, so this is a valid A, and similarly all the others are also a valid A. Okay, now we had to find how many valid A's are possible. If they are possible, then just print the count. If they are not possible, then print 0. If they are infinitely possible, then print -1. So now we'll cover every case one by one. Okay, first we will see when is the case when the count becomes what, 0. Okay, minimize the Chrome. Okay, I'll minimize the Chrome now. Should I minimize the Chrome? Okay, let's minimize the Chrome. Let's say my B is 2, 4, 6, 8. And let's say my C is what? 4, 6, 8, 10. If you see, this is C is not possible. The reason for that is this 10 is not present in B. Since this 10 is not present in B, therefore this 10 could never be a common element between A and B. Okay. Hence, the answer for this is C. And that is the only case when you actually get a 0. But if you see, okay, let me even write the constraints. Let me write the constraints. If you see, okay, so starting index, like starting value can actually be from -10 to the power 9 to 10 to the power 9. Okay. Difference can be again from 10 to the power 9 till 1, from 1 till 10 to the power 9. I didn't remove this. Okay. And n can be what? N can be from 2 till 10 to the power 9. And you're given the starting value, the difference value, and n. So in order to find all the values, you need to check like all the values present in C are present in B as well. How do you do that? You're actually given like start of C. Okay, let's say, let me call start of B as what? B1. Let's say this is B1. Okay, let's call difference of B as what? BD. And let's call size of B as Bn. Okay. Similarly, so this was for B. Similarly for C, we have C1, that C is starting from C1. It has a difference of CD and the size of this is Cn. Now given these values only, and you need to check every value present in C is also present in B. Now if you see, if the first value is present, first value of C is present in B, and if the last value is also present in B, then you can see, say, all the values in the middle were also present. Basically, if your C is C1, C2, C3 till C of n, and let's say your B1, we had C as C1, C2 till C of n, and our B was B1, B2, B3, B4, B5 till B of n. Okay, we know that C1, C2, Cn are all common elements of A and B. Okay, that means if the first element of C is present and last element of C is present, let's say first element of C was present here, last element of C was present somewhere here, then all the elements in the middle would also be present somewhere in the middle. So you'd only have to check for the very first value and the last value. Okay, now how to check if C1 is present in this? That can actually be checked by, okay, so C1 should be, what are all the cases in which C1 will be present in B? C1 should be greater than equal to B1. That is the very first case that you need to think of. Okay, because if it is smaller than b1, that means the c1 is not present in b. The other case is that c1 minus b1. This is the difference between c1 minus b1. Okay, so let's say in b, c was present somewhere here, c1 was present somewhere here, and b1 is here. Okay, this is the difference. This difference should actually be a multiple of bd. Okay, so c1 minus b1 percentage bd should be equals to 0. Okay, and one more thing, what if this c1 is present outside this b? Okay, in order to see for this, you need to see that c1 minus b1 by bd should be less than bn. Because if you see, where is b2 present? b2 is actually present at b2 minus b1 upon bd. b2 minus b1 is what? bd only. bd by bd actually gives us 1. So that means b2 is present at the first index. So this is 0, 1, 2, so on. So basically, the last value bn will actually be present at n minus 1. Okay. Therefore, c1 minus b1 difference divided by the difference of the AP should be less than bn. Then only we can say that it is present somewhere in the middle of the series. So these are the three conditions that you need to ensure if a particular element is present in a sequence. Okay, so you did the same thing for C1 and then you did the same thing for Cn. But to do this for C1, you actually need to find Cn. And the last element of an AP is actually written as a plus n minus 1 into d. Okay, a for C is what? C1. N for C is what? Cn minus 1 into d is Cd. So essentially, C1 plus Cn minus 1 into Cd will be Cn. You check for Cn as well. Okay, if both of these elements are present, then you can say that the answer is 0. Sorry, that it is possible that every element in C is present in B. Therefore, the answer is not 0. But if there is a case that either C1 or Cn is not present in B, then you can say that the answer is 0. So 0th case is done. Let's move to, okay, just a second. Okay, there is one more thing that I actually left. Okay, what if this difference is not a divisor of this? What if for this case only, okay, we actually made an arbitrary sequence, which is that possible? I don't think, like if we made 2, 5, 8, okay, I don't think it is of any use. Okay, let's skip this part. Okay. Cool. So these are the conditions. Okay, you have to first check for C1, then Cn. If any of these is not present, then the answer is 0. Now let's come on to C1. Let's come on to minus 1. Okay, I actually need these. D and this is. Now, the next thing that we need to check is whether the answer is minus 1 or not. Now, how do we see if the answer is minus 1? Let's say this is B, or yeah, let's say this is B and C is, let's say 6, 8. You will see that you can actually append in the next turn 10 also, then maybe 10 and 12, then maybe 10 and 14, and so on. You can keep on appending, okay, in this, and this will be your A. Therefore, you can say that there are infinite answers. Okay, therefore the answer of this is minus 1. What are the other cases in which you are getting minus 1? The other cases would be, what if you had 2 and 4? Then you might have used a 0 here. Okay, this would also have been a valid A, or maybe minus 2 also, maybe minus 4 also, and so on. Again, for this also, you actually get infinite cases. Okay, I hope everybody is able to follow up. Okay, little tricky. Uh, okay, now let's say let's say we had a B which was this. Let's say this is B. These all gaps are actually for B. And let's say our C was present. One was present here. One was present here. One was present somewhere here. We already know that the answer of this is not 0 because we have already checked for the first value and the last value. The only way of getting answer as infinite is either we can keep on adding values in the right, or we can keep on adding values in the left. Okay, let's first see what happens if we try to add a value in the right. If we add a value in the right, and if that value is already present, let's say we tried adding another value which will be here, and if that value is already present in B, okay, that means you cannot add any values on the right side. Because if you add that value in A, then A and B will have a common value, and this should be present in C as well. But since it is not present in C, that means you cannot add that value in A. Similarly, for the left side also, you will check one previous value, then the sequence. Your sequence was starting from here. You will see if a previous value in this sequence was already present in B. If it is present in B, that means you cannot add any values on the left side. Because if you add A and B, both will have a common value, and that common value should be a part of C. But since it is not a part of C, that means you cannot have this value in A. Okay. So for -1, the case becomes either you should be able to add values in the left or in the right. Which means if you're able to find any direction in which you're able to add values, then the answer is -1. But if both the values, let's call this previous value and let's call this next value. Okay, previous value is nothing but the previous value of the sequence in C. Next value is nothing but the value after the last value in C. If both these values are present in B, that means the answer is not -1. There is some finite answer. But if any of these values is not present, that means in that direction we can keep on adding values and you will get a valid A. Therefore, the answer is -1. Okay, so -1 is also done now. Now the only case left is when you actually have a certain answer. Okay, now how to do that? A way of doing that would be, okay, let me just remove these now. I don't need these, and I don't need this as well. And let's say this was my B. Okay, I'm making this as a B. This is my B. Let's say my C was this. Let's say in C I only had two values. Okay. Now I know that the previous of this C would be this value. Okay, this value. But this is already present in B. The next of this C would be this value, but this is already present in B. Therefore, there is a finite case in which I'll actually have this is a finite case. I'll actually have finite number of values possible for A. Now, you know that in your A, you need to at least insert this value and this value. Okay. You also know that, okay, let's say you actually found some D through which if you add this value, this value, this value, this value, any of these values won't coincide with this and this. Okay. Let's say you are able to add like how many values? Let's say you are able to add 3 values in between. Okay. In between these two C's, you are able to add 3 values. You need to make sure that these 3 values don't coincide with these 2 values. That is the first thing. The next thing that you need to ensure is that you cannot add more than 3 values in this side. Because if you add the fourth value, this fourth value will actually be this only. So you need to find this difference and see how many values can you add in this difference. Similarly, for the right side also, you need to find this difference and see how many values can I add in the right side. Let's say I was able to add X values here and Y values here. Your answer will be X plus 1 into Y plus 1. The reason is that you're able to add 3 values here, and let's say 3 values here. Okay, your answer would be 4 into 4, which is 16. The reason is that one case, or let's say you're only able to add, for simplicity, let's say you're only able to add one value. Okay, your answer would actually be 1 plus 1 into 1 plus 1, which is 4. Reason is, you can either, first sequences, you can either consider this one only. Next would be, you can actually consider this. Third will be, you can actually consider this. Fourth will be, you can consider all these values. So 4 cases. Okay, now I hope this part is done. Now, how to find this D? Because after we are done finding this D, all we have to do is find how many D's can be present in this side, find how many D's can be present on this side, then multiply them. Okay, now how to find this D? Let's see what are all the characteristics of this D. So if you see, we had a value here and a value here. Okay. Now we know that this D, let's call it what? D only. Let's call it D only. Okay. This D should be divisible by CD. Because then only when you keep on adding values, one value will coincide with this one. That is first thing. Next thing you need to ensure is that any of these values should not coincide with this one. Okay. Let's say this is D only. We know that this is BD, difference of B. If we find D, the LCM of B and D and BD, LCM, you will actually be able to find the value at which point this D and this BD will coincide. All you have to make sure is that this B and this BD should coincide after this value. Because if they coincide after this value, that means they will never be able to coincide, because after this value, again, another loop will start. So you need to make sure that LCM of D and BD is what? Greater than equal to what? Greater than equal to CD. Or equal to only, you'll actually see that this is always equal to. Okay. Whenever the LCM is greater than equal to CD, that means you can actually consider this D, because this D will coincide either at this point or after this point. Okay. And none of the values in the middle will coincide with the other values. Okay. So what you need to do is first find all the divisors of CD, because the first condition is that D should be a divisor of CD. Okay. Then, okay, sorry, CD percentage D. Okay. Then for every divisor, you check if the LCM of that divisor and BD is greater than equal to CD. If it is, then find how many values can you fit in the left side, how many values can you fit in the right side, and then multiply them, and that is the answer. That's it. That is how you have to solve this problem. Now I'll actually show the code as well, and maybe some of the things will become simpler from the code. Okay, pretty long problem. Okay, let me show the code. Okay, so I'll just explain like what I'm actually doing here. Okay, okay, so as you can see, I've taken the input, which is B1, which is actually the starting of B. BD is the difference of B. Bn is the number of values present in B. Similarly, C1 is the starting of C. CD is the difference of C. Cn is the number of values in C. Now, this C end is actually the last value of C, which is A plus N minus 1 into D. So, A is C1, N minus 1 is Cn minus 1, and difference is CD. So, this C end actually represents the last value of the sequence C. Now, if you remember, in order to check for 0, we had to see that the first value of C, last value of C, and CD should be a divisor of BD. Okay. So these were the conditions that we had, that if the first value, that in order to have 0, okay, either the first value should not be present in B, or the last value should not be present in B, or this part, that it is not a divisor of the difference. Okay. If any of these cases is false, then you can say that the answer is 0. I've written this generic function in which I actually check if C1 is present in this sequence. And how to check this part I actually explained it already in the like on the board, so I'm just gonna skip this. What I'm actually doing is I just have to see that the value that I have to check should be greater than the start. The difference of value and start should be divisible by difference, and the number of values that it can accommodate should be less than n. Okay, cool. So this is this function. So 0 is complete. Then let's come on to -1. In order to have our answer equal to -1, we knew that either the previous value of the sequence in C or the next value of the sequence in C should not be present in B. If any of these values is not present in C, in B, then the answer becomes -1. So that is exact same thing what I've done. C previous is nothing but one value previous than the starting of C, which is C1 minus CD. C next is nothing but C end plus CD. I'm checking for both these values here. Okay, both these values here. Okay. And if any of these values is like not present, then I just say -1. Then I come that if both these cases are not present, okay, then that means I have finite number of possible cases for A. How to find this? The first thing that I do is that we had to do was we need to ensure that the difference of A will actually be a divisor of CD. So I wrote this function divisors of number. In this function, I'm just returning all the divisors of a given number. Okay. So divisors of number returns me all the divisors of this CD. Then for every divisor, let's say my divisor is AD. This AD is a possible candidate for my difference of sequence A. I need to see that the LCM of D of A and what BD should be less than CD. This condition, okay. This condition that LCM of D and BD should be greater than equal to CD. Then only I have an answer. That means if it is less than CD, then I don't have an answer. Okay. So what I'm actually doing is if AD. So this is how you find actually LCM. LCM is nothing but if you have to find the LCM of A and B, all you have to do is product of A and B divided by GCD of A and B. So that is exactly what I've done. LCM of both these values, if it is less than CD, that means you cannot consider this. Okay, because this value will actually make some other value coincide. Okay, so you can't consider this case. But if that is not the case, okay, you just need to find how many values you have on the left side. Okay, how many values do you have on the right side? Okay, and then like find the mod and then add them to the answer. Okay, this small function does nothing but just finds how many values I can accommodate, which is n by d minus n%. Okay, so that is how you solve problem D. Again, I'll copy this code and put in the live chat. Problem D. Okay, cool. Okay, so I hope this is enough for this stream. We covered problem A, B, C, and D. Okay, and I am pretty sure like everybody will be able to understand A, B, C, D now. Okay, if you still have any doubts, just go back into the stream and watch like how I did it. I've already pasted all the links in the chat. And yeah, I think that's it. I think we are good to end the stream. If anyone has any problem, they can ask me, or else I can end the chat in the stream. And the next contest is on, I think, second. I think it's a Div-3 contest, and we have 2 consecutive Div-3s. Okay. Okay, so the next contest is on second, which is a Div-3 round. Then we have another Div-3 on 5th. Nice. Then we have a Div-2 on 6th. Okay, cool. We have a Div-4 coming as well on 10th. Okay, cool. Okay, bro, I want to know what is the max size of the array we can declare inside main. I think you can make an array till the size of 10 to the power 6, like somewhere around 10 to the power 6 only. Like it's something a little greater than 10 to the power 6. I don't remember the exact value. You can just Google it up. Okay, cool. Okay, I think I'm gonna end the stream now. If any case you still have any problems, you can just comment down below. I'll probably answer all your problems there. Okay. And yeah, I think that's it. Do like the stream, guys, and make sure you're subscribed to the channel as well. I'll be coming with more streams like this. And yeah, thanks. Bye bye.